Yeah, I think you can start. Yeah.
Okay,
So please.
so we
Yeah.
can start our 10th lecture.
Yeah.
This 10th lecture will talk mainly about quadratic element, and we started last lecture with quadratic elements also. Okay, and we will continue today with quadratic element, and maybe the coming lecture also we will start with quadratic elements. Okay, because it is a bit long time. We have to spend a long time, I mean, in doing things with quadratic element. Today we are going to divide the lecture into two parts as we usually do. The first part will talk about quadratic elements, continuous and discontinuous elements. We need to read the results. We need to read the results. What are the results of the quadratic element? Then we will talk a bit about interpolation using quadratic element. We'll give it as a rules. We will justify from where these rules comes, but next time we'll justify more. Okay. Okay. So if we start with quadratic element, our map of today, quadratic elements, we will start reading output of computer programs. This is very important. This is very important. And also, as far as we talk about output, how to put the input, how to submit the input for such quadratic elements. We'll talk about input also. And when we talk about inputs, we'll talk about two elements, continuous element and discontinuous element. Okay? Then we will move to numerics. Numerical implementation. Why we talk about quadratic element? Because we initially talked about constant element. Okay? Then we talk about quadratic element. In between we have linear element, and after that we have cubic element. Actually, start from quadratic element, we have general element. We could have this element, curved element, or something like that. Okay? When I talk about reading output, this part, when I talk about this part, for example, we talk about input and output, I will cover 2D elasticity, and I will cover plates in bending. I will leave these programs in the drive. You can download these simple programs and you can try it by yourself. In elasticity, I'm going to use the programs in this book, which is a boundary element introductory course by Carlos Brebia and Jose Domingos. This is one of the early books in boundary elements. I'm going to use these programs for elasticity. And in plates, I wrote another program, very simple program for plates using quadratic element. And this was the first version of our software, the PLPAK software. Okay, and it was written at 1995 or something like that. Okay, it has the same input and output like this the programs in this book. Okay, so if we started talking about two-dimensional elasticity, I will start, if I have a program, for example, if I have program for two-dimensional elasticity, and this program, I have to make input for this program, I'm concerned mainly about reading outputs. Okay, so we have program, for example, this is computer program to solve using 2D elasticity using quadratic element. This is the same program in the boundary element introductory course. This program, it has only continuous elements. The program that I'm going to give it for you for plates, it has continuous and discontinuous element. So you have input and you get output. Okay, so if we have problem like this, we have bar under tension, we put Poisson ratio equal to 0, and this is in 2D elasticity. Okay, and we have G equal 0.5 times 10 to the power 6. It is 1 meter times 2 meter length, and it is fixed from this left side. And as far as we talk about 2D elasticity, we consider plane strain or plane stress problem. We have the out of plane depth is 1 meter. This is from the theory of elasticity. We are going to discretize it like this. So we have the first element, second element, this is the third element, and this is fourth element, fifth element, and this is the sixth element. Okay, so we have continuous elements like that. We will choose our, this is x and this is y, or x1 and x2, and we have three internal points, point 1, point 2, point 3. We want to compute the values at this point. We define that these are the extreme points. These are the extreme points. We define these points as extreme points for the elements. Okay, so these blue points are extreme points. This is what we call it, extreme points. We define these points are internal points. This one is element or boundary element. These are nodes. So somehow we are going to discuss how to place the input. It is the same like plate bending. We don't care about it now. We will obtain the result like this one. The most important thing in the results, you will get results for our result. It has boundary values, and we have internal values. In boundary values, we have two things. We have displacements, u1 and u2, and we have tractions. And the internal points, we will have displacement, u1 and u2, and we have stresses, sigma 1, 1, sigma 1, 2, sigma 2, 2. Tractions here, this is very, very important to know. In tractions, for example, we have, this is the first element, this is the second element, this is the third element. In the first element, you will have the first node, the second node, the third node. Okay? In the second element, you have the third node again. In the third, you have the third node again. That means that you have traction before and the traction after. This is very important. For example, at this node, you will have the traction before and the traction after. The traction before belong to this element, the traction after belong to this element. This is very, very important. This is very, very important to know. Okay? So, if we read these traction values here, for example, here in the third node, where can I see this one? Okay,